Okay, so here are your notes on zero and also negative exponents. And just as you've been doing, take careful notes on each of these 9 problems plus a few rules. And then tomorrow you'll have some practice. Pause this, rewind as you need to. This can be a little confusing, but hopefully with a couple days practice, it will make sense. So what we have here, we have been seeing negative exponents, and we've just been treating them as you should, like any numbers where you add and subtract them. But now we're going to add in the rule that, generally speaking, you don't want your answer to be left with a negative exponent in it. Negative exponents have meaning, but in a problem is considered simplified, written with positive exponents. So for that, we're going to look at this rule right here. Negative exponents, literally what they mean is if you have a number to a negative power, so like this, x to the negative n, it literally means the reciprocal. So that's the same as 1 over x to the positive of whatever that negative n was. So let's just see how that rule applies for number 1. So 2 to the negative 4 power. In theory, like what exponents normally mean is you repeat that 2 however many exponent times, but you can't really repeat 2 negative 4 times. How would you even write a negative number of times? So the way we deal with this is we say 2 to the negative 4 is the same as 1 over, so we flip it over, and that negative 4 becomes positive. 2 to the positive 4. Now we could take that 2 to the 4, and now that makes sense to repeat it 4 times. That is the same as 1 over 2 times 2 times 2 times 2, which is 1 over 16. And that would be our final answer. Okay, so number 2, applying that same rule, 4 to the negative 3 power. Well, we rewrite that first with 1 over 4 to the positive 3. And then you can use your calculator for this, or mental math. 4 times 4 is 16, times another 4 is 64. So 1 over 4 to the 3rd power is really 1 over 64. Okay, number 3. Now, the base in this case is a negative number, but that's okay. We use the same rule. So this is negative 5 to the negative 2 power. And so we have to flip this over. And it's important that the negative 5 is in parentheses, because what that means is the negative 5 is the base that's repeated. But we can't repeat it negative 2 times, so we have to turn this over and say that's the same as negative 5 to the positive 2 power. Well, what that looks like is negative 5 times negative 5. Because the negative 5 is in parentheses, you repeat it twice. Negative 5 times negative 5 is positive 25. Okay, well that is similar but different to number 4, because you notice that in this case, on number 3 there were parentheses, and number 4 the base is not in parentheses, so actually the base is just 5, not a negative number. And the way that looks is this negative kind of sits out in front, and the 5 to the negative 2 gets flipped over and becomes 1 over 5 to the positive 2, where the negative just lives out in front because it was not part of the base that's repeated. And now this is 1 over 5 times 5, which is 25, and the negative comes along for the ride. And so in that case, the answer is negative 1 over 25. Okay, so that's how we deal with negative exponents. We rewrite them as positive exponents and then simplify. Now, starting with number 5 here, we're going to use this other rule that basically is a very simple rule. Any number to the 0 power is equal to 1. It doesn't matter what that number is. We'll get in later to, there's a lot of debate about what if you have 0 to the 0 power, but for now, let's just forget about that and just say any number, whether it's positive or negative, if you raise it to the 0 power, by definition, it's equal to 1. So this is pretty easy. 7 to the 0 power. Any number to the 0 power is 1. to number 6. Negative 3 to the 0 power. The base is negative 3, but it's raised to the 0 power, so the answer is 1. So you see how that could go on and on and on. Any number to the 0 power is 1. Okay, so these last ones are, we're going to actually substitute in, and the key here is when you substitute, you're going to use parentheses. If you don't, you will make a mistake at some point. So, number 7. We're going to evaluate m to the negative 2 power when m is 2. So instead of m, we're going to put a parenthesis, and in place of m, we're going to put a 2. And now we follow our rules. 2 to the negative 2 power is the same as 1 over 2 to the positive 2 power. Well, 2 times 2 is 4, so that is 1/4. Now the real reason why you use parentheses when you substitute is if you're using a negative number, and that number is going to be to a power. And I think that might happen on number 8. So here we have 2 times, instead of m, we're going to put 2. Instead of n, we're going to put negative 3. And only the n has an exponent. Okay, so the way we deal with this is everything that has a positive exponent is happy where it is, and that would be the 2 and the 2. The negative 3 has a negative exponent, and we need to move that to the denominator. So the 2 times 2 stays on the numerator, and now the denominator, the negative 3 to the negative third goes to the bottom and becomes negative 3 to the positive third. So before there was a denominator there, and it was just equal to 1, and now this moves to the bottom because it becomes its reciprocal. Now we can do our simplifying. 2 times 2 is 4. This is literally negative 3 repeated 3 times. So 3 times 3 times 3 is 27. Negative times a negative is still a negative, so that's 4 over negative 27. And it's actually customary, if you have a negative on the bottom, to write the negative on the top instead of the bottom, so this is negative 4/27. Okay, and the final thing we have is negative 3. We're going to put in, instead of m, we put our 2, and that's to the negative 3 power. Instead of n, we put a negative 3, although it doesn't really matter what it is because it's to the 0 power. So that's going to give us negative 3 times 2 to the negative third times, and that's just equal to 1. The 2 to the negative third can go to the denominator, and the 1 is not a factor anymore, or it is a factor, but it doesn't change the value. So we're going to go negative 3 over that 2 becomes to the third power. And if you know 2 to the third power is 2 times 2 times 2, which is 8. Okay, so those are your notes for the day. You will have problems just like this for practice tomorrow, so make sure you really understand this as you take your notes. Pause, rewind, do what you need to do to make sure you understand